What page are we supposed to be on?
We're going to do, we actually start, let me tell you, is that in your way?
No.
Try to adjust it so they can actually see what I'm writing. We'll see how that goes. So far we've been kind of doing lots of algebra review stuff, right? And we're going to keep doing that. We're actually going to do a couple sections out of chapter 2. Okay? In fact, we will do review today, Monday, and Wednesday. Yeah, that'll get us. We're going to do 2.3 now, 2.4 Monday, 2.5 on Wednesday. Okay? I think that's right. It is indeed. Okay. So again, I'm hoping most of this stuff is, you've seen it before, maybe a little fuzzy, but it shouldn't be much new stuff. And so that means this is next Wednesday. So I'm thinking Friday we will review, and then a week from Monday would be our first test. Okay? So first test, a week from Monday. The next chapter we're going to do is logarithms and exponentials and that kind of stuff. So we'll talk about how fast bacteria grow. Okay? And so if you've had 94, some of it will be familiar, and then we're going to, take every idea in 94 and go a little farther with it, basically. Okay? And then that'll take a couple of weeks. We'll do then medical dosage calculation stuff. And I think you'll find, how many of you have chem? Some of you. So if you had chem, it's going to be easier. If you haven't had chem, then this will make chem easier when you get there, okay? So it kind of depends on, but we'll do that for a few weeks. Actually, that's going to be the shortest one. And then by then we should be almost halfway through the semester. And we start into more probability statistics to get you ready to take stats. So this would be kind of the prereq piece for stats. Okay? And so as we went through that was 3 different textbooks we've kind of stole from. Okay? Is everyone okay with?
So the test is the 17th?
I think that could be right. Yeah.
A week from Monday?
A week from Monday, whatever that comes up to be.
Yeah.
I mean, again, we'll have a review on Friday, and
Yes.
so we'll be talking more about it. Okay. So first, let me run through a bunch of vocabulary. I don't know, maybe it'd be helpful for you to just kind of see it up there. But so when we talk about x, there's a lot of different ways we describe x. One is the independent variable. And when we talk about y, it's the dependent variable. In other words, what we're saying when we say independent variable, we get to pick what x is. And then y depends on what we picked. Okay? Right? But there's another bunch of words that go along with this one. Well, this is what we refer to as the domain. I think you've heard that before. And this is the range. And when we talk about functions, we also use the word, oh, that's funny, I just lost it. Okay, but anyhow, we can use the word input and output. So again, depending on the context, these are all different ways we would refer to y, and these are all different ways we would refer to x. All right? Okay. So now let's talk about functions. I could write an equation. Looks rather harmless, right? And everyone's familiar with that format? If I rewrite it like this, you familiar with that notation? Some of you maybe not quite as familiar. So these are the same. There's one little exception, but really the way you could read this is this equation is named f. Sometimes we might choose not to use f, and maybe we'd say this is equation h. And this part here simply tells you what the variables are. Okay? Our variables are x's. If I have, z, then I would say over here my variables will be z's. Okay? So you think about this as being the name. This is the type of variable. This is not multiplication, okay? You wouldn't be trying to divide by x. And let's see, one more piece of trivia for you. A Swiss mathematician named Euler came up with this idea. Okay? If you like it, that's fine. If you don't, we just have to live with it, I guess. Euler was actually a nice guy, though. He was super bright. He would write papers, multiple math papers a week. But then he was actually kind of a nice guy.
That's the slope-intercept one.
Yes, that would be. Mm-hmm. Yeah. So the only thing about the only difference between these two, I could have. When I use this notation, what it says is that these guys are functions, and that's the next word then that we need to define. I think you probably encountered it before, but I want to kind of run right back through it. Okay. So then let's talk about what we mean by a function. Let's say I want to convert from Celsius to Fahrenheit, okay? And so I make this little program on my calculator. So here's the program. And so if this takes Fahrenheit and converts it to Celsius, I should be able to say, okay, 78, plug it in here, little program does some math on it, spits out an answer, right? And in fact, inside of here I would have that f of x is equal to, that's going to be Fahrenheit divided by 1.8. No, well, it depends. You're thinking we can use 9/5 or 5/9, or I can multiply or divide by 1.8. So it depends on how you want to do it. Yeah, that's what you're going to, right? Yeah. So in this case, I'm going to divide by 1.8, and then I need to I need to subtract 32. Then here we go, minus 32 divided by 1.8. So that's my little equation in there, right? So I plug the 78 in. What pops out? Somebody have a calculator? I think that sounds about right. 25.5 degrees Celsius comes out. Okay. So of course the idea of this being an input and output, that makes perfect sense, right? The input is 78 degrees. The output is 25.5 degrees, right? So that's easy enough. What's important here, and this is where the definition of function comes in, if I plug 78 degrees in here, I only get one answer out. This will never give me 2 answers or 3 answers, right? So that's what a function is about. In other words, a function is a special type of equation where if you put in one value for x, you always get one value out for y, okay? Now, in fact, I could change this. If I put a little 2 right here and squared that, this went from being a function to not a function. And let me give you a simple example. If we have x equal to 2, and I plug it in here, so I have 2 times 2 plus 3, and I get 7, right? Now, if I were to try again, but let's say I make x equal to negative 2, well, that's bummer. Bad example. And it's even documented, right? Hold off on that one, okay? I'll do better. If we're to make a graph of this, it ends up being just kind of like a line like that. Along here is Fahrenheit. Along here is Celsius. So in this case, what we did is, here was 78 degrees. I went up, I touched the line, went over here, and here was the 25.5. Okay? So, one of the things we do is what we call the vertical line test. If I were just to go along my graph, notice that my vertical line only crosses at one point, right? Never crosses more than once. So then let me show you a graph that wouldn't be a function. So maybe my graph does this. And you can see if I were doing the vertical line test, we're all good here. We're all good here. And then right there, I would cross 3 times. You can see that? Right through there, I cross my graph 3 times. So if this is one x value, maybe that's x equals -4, right? What happens is I get out 1, 2, I get out 3 different answers for y. Looks like y might be equal to -2, +2, and maybe 4, right? So this is what we mean by not a function. Okay? You plug in one value of x, and you can get multiple values of y out. Okay? Good so far? Another way this would show up, coming back to this example here, we have that x is 78, gave us a y value of 25.5. And you can imagine I could pick another temperature, I could pick 54 degrees, and I'm going to have a different value for y come out, right? For Celsius. And so I could have a whole bunch of these listed out. 32 degrees would be 0. 212 degrees would be what? So this is freezing, right? Boiling is 100. There you go. Okay. But the bottom line is, every time I put in one x, I get only one value of y out, right? So if you were to see a list of points like this, so let's say I have 2, 3, 4, 5, and 2, 7, and 1, So just looking at the data points, we'd say this is not a function. And the reason is, it shows right here, sometimes when I put a 2 in, I get a 3 out. And sometimes when I put a 2 in, I get a 7 out, right? That's another way of showing this exact same problem right here, right? So what I'm saying is you can look at a graph, and it's really easy to tell that it's a function or not a function. This is not a function. That's a function, right? If you're looking just at a list of points, again, anytime you have 2 y values out for the same x value in, it's not a function. Okay. And really, a lot of the stuff we do, we like to be kind of like this. It's like your calculator. If you put in a number, you want the same number out every time, right? So functions are actually good from that standpoint. So we're doing okay with functions? So we have a couple different ways to be able to check if something's a function or not. Okay, one other little way here that you'll see it asked in your homework. So I can't quite project that down, so if this is my domain, so these are all the x values, right? And over here, this is my range. So these are all my y values. And so in fact, I could pick on this. Another way they would do that same list of numbers would be like this. We'd have 2, what do I have over there? 4, and 1 for x values, right? So again, I'm just looking at these. So then the y values, we have 3, 5, 7. Okay. So the 2 gave us a 3 out, and that's fine. And the 4 gave us a 5 out, and that's fine. The problem was when this 2 gave us a 7 as well. So as soon as I did that, this then became right there. That was the glitch. That made it not a function, right? Now notice we also have that 1 gave us a 7. So oops, that should have been in blue. So that was just fine. So again, this is another way you'll see in the book. They'll talk about it, is a function or not. And so in this case, what they'll talk about is a mapping. Does one value of x map to more than one value of y? Now it's okay if it kind of is the other way around. For example, what if I only have a 6 over here? All of them can map to one number, and that's okay. It's not if the issue is if this maps to more than one number over here. So in other words, it's possible to have something really boring where every time you put a number in, you get the same number out. So we still have a function there. And in fact, here's what the graph would look like of that. Just like here, a 6. So we're saying that when x equals 2, when x equals 4, when x equals 1, we always get a 6 out. Are you okay with that comparison? And of course, you can see that would pass the vertical line test. Good with these words so far? Okay. I know it seems a bit abstract sometimes, kind of mathy stuff. Why didn't I use that red pen? Well, I did have a cap for the black one. So here we have three equations, and the first question is, what's the domain of range? And then the third question is it a function or not? Okay. So let's just kind of work through these guys. Okay, so first question is, what is the domain? In other words, what are the x values that we can plug into this equation? And we start off with the idea that any x value would work. Anywhere from negative infinity to positive infinity. Okay? So there's a couple things we really want to look for. One would be if our denominator somehow would become 0. Everyone's aware of the issue there, right? Division by 0? Okay. The other thing we want to look at are square roots. Do we ever end up in a situation where we're trying to take the square root of a negative number? And the third one is, if it's more of a story problem situation, is there something that just can't happen? So for example, if we were talking about weight, what values of weight would not be acceptable?
Negative.
Negative weights, right? Doesn't make any sense to weigh negative 5 pounds. Okay? So the domain would be, we'd say anything greater than 0 could be a weight. Okay? So there's really kind of three things to watch for, whether it can really physically happen. Look at the denominator, and then look for square roots. Okay? So what value in here would make that glitch? Division by 0. Right? So we can look at it and say, x cannot be equal to 5. Or another way to write that would be, we can go from negative infinity up to 5, but we can't use the 5, right? So we'll go with the square bracket. And then we combine that with 5, comma, positive infinity, like that. Oops, sorry. Correction on that. This is curved. In fact, a good way to think about this would be when you're using the square bracket, it's like saying greater than or equal to, because it would include it. And when we're using a curved, it's greater than or less than, but does not include. Okay? So then this would say up to 5, but not including 5. Then from 5, but not including 5 on up to infinity, but you can never get to infinity either. Okay? So that would be our domain. Do you guys have your calculators on you? Or actually, anybody know what that looks like? It's okay. Another class. So grab your graphing calculator. Let's do this real quick. So hit your y equals. If you know how to do it, just do it, but I'll kind of walk you through it if you don't. So we're going to put in -7 divided by, and we'll need parentheses, x minus 5. And do you guys know how to do the windows? Okay, so the second step would be click on the window right beside it, if you're ready. And actually, this is pretty good. It's going from x being -10 to +10. Ah, fair question. It's right here. Want me to back up a little bit?
Yeah.
Sure. And the negative here, it needs to be this key. It can't be this key. In fact, I'll recognize the difference? This one is subtract. This is negative. Okay. So we actually use the negative. So then you click on your window, and right now it's -10 +10. Y is -10 to +10. So that's just telling us how big the display is. Okay. And then we would just come over now and hit graph. There we go. And actually, this line right here, some of your calculators probably don't give you that line, right? That's good because it doesn't really exist. Because what's really happening here is it's coming along here, graphing, and it's going on to infinity, right? But then the calculator is not smart enough to pick the pen up before it starts. It just keeps the pen, it kind of drags the pen down, and then it starts graphing again. Okay? So that's really what's going on. And so then right here,
That's going to be at that 5, right?
that's at the 5. It is. Mm-hmm.
That bottom curve would never reach 0 though, right?
Let's see here. Yeah, actually, I shouldn't have crossed there. Good. No, thank you. Thanks, Abigail. So now when you look at it, you can see from the domain point of view, we're going from -infinity up to 5. We've got a little glitch right there. And then it continues on. And then in the y direction, you can imagine, this of course is going down forever. So our range is everything but, can you tell one spot it's not? Back to your 0 point, right? Yeah, so right here, right there exactly at 0. So then let's write down that our range would be, so y can't be equal to 0, or this is the way your book is going to want it. So it's going to be from -infinity, comma 0, 0 to +infinity. And actually, I don't think your textbook will want the plus in there. Excuse me, Pearson, my lab stuff. Okay, so we have the range domain. Next question is it a function? And it's easy to tell. It's kind of hard to tell just looking at it here. But you can do your vertical line test. And so we never cross our graph more than once at a time, any place, right? So then we could say that it's a function. Is a function. And the reason, again, when I'm doing the vertical line test. Yep. Yeah, because we can't just start plugging. You can plug some values in, but you'd have to plug really a ton of them in to know if there's going to be that glitch.
So wait, you're supposed to choose, so for the value of x, you're supposed to choose something that's going to make the denominator 0?
That would be the limitation on the domain.
Okay.
Yes. So we said if x were 5, We have division by 0. So what we're saying, that's the limitation. This is correct, a correct way of writing it, but I'm pretty sure that Pearson will want it written out that way. Yeah, it takes more. Mm-hmm. Another way I think is more intuitive.
But you could also say like x would be 15 or something like that too, right?
Yeah. Mm-hmm. Let's see, it's going to be actually be less than 5, greater than negative infinity. You could do it that way too, but this notation's not. This used to be the more common notation, and it's not being used as often. It's going more to this thing. I think this actually is easier to read. Yeah. But that's, I guess it took too much room in the back of the book. Okay, so let's try a few more of these. So let's do the next one down. We have y equals square root of 4 minus x. So the first question is, what would be a restriction to our domain? In other words, can you think of numbers that would cause grief?
4.
So if we put a 4 in, what's the square root of 0? Does that work? Well, you're close though. So don't retract your statement too quickly. So 4 itself would give you square root of 0, which is okay. So, but what about 5? Right, so a nice way to say that would be x must be greater than or equal to 4. Because 4 itself, just a second.
You can square root of 0 because it's 0, right?
Right, yeah, so it can include that. So let me change that the way x can't be. Come on. Less than or equal to 4. There we go. X could be less than or equal to 4, right? Because I can put a 3 in. I could put a negative. I could put a negative 5 in. That'd be fine. On down. So right there at 4 is the break point.
Wait. Okay. Yeah. Okay. Sorry.
Okay. So then let's try to write it out the hard way. So we're saying that x can be equal to 4 or less than. So we'd go from negative infinity, comma, 4 square bracket. Because we can include the 4. Right? Okay, let's talk about the range. And sometimes the range is easy to see is if we graph that. So go ahead and graph a new one here. So let's pull up the calculator. So we'll just put that in and graph it. So we end up with something like that, and this point right here is 4, right? Okay. So we already know the domain is everything up to there. Now the range would be, what does it work down here? There's nothing down here, right? The smallest y value we have would be the 0, right? Okay. And then this just grows, and I got to be careful I draw my picture. It grows forever, kind of slow, but grows and grows, right? So then we would say then the range would be anywhere from 0 up to positive infinity. And again, I'll go square bracket because it includes the 0. And then we look at it, we do the vertical line test, and it's pretty easy to see that.
Why do you have brackets there instead of just the parentheses?
The square bracket?
Yeah.
That means that it includes the 0, includes the 4. When I make it curved, it's less than 5. up to, but just slightly less than 5. So everyone agrees, though, that would be a function? Okay, good. I'm going to get tight on time here. I need to do 2 more problems for you. Okay, so then the next one we have x squared. And looking at that, is there any value for x that doesn't work? Negative a billion, that's fine. Positive a billion is fine. 0. Okay.
Only when the exponent is a negative or something like that, it wouldn't work.
Right, that's true, because then it would put it back in the denominator. Yeah, good example. So here we're saying the domain would be just negative infinity up to positive infinity. And before we graph it, can you think of any values for y that won't show up? So if we were to pop that in our calculators again.
Would be anything negative, right?
Would be or can't be.
Why couldn't it be negative?
That's exactly right. Yeah. So let's go and graph that, and we should be able to see that really clear. So you're going to put in x squared, and we get that, of course. That. So you're right over here. Our range then is going to be from, it could be 0, or on up to positive infinity. So there's our little limitation there. And is it a function? So I think it's going to be, we only cross once any point in the graph, right? So then we're a function. If this had got laid sideways like that, then you can see that would be not a function, right? And that one actually would be x equals y squared. Just kind of give you an example of when it doesn't work. And I think I can do the one more example we have here. Nope. There we go. Let's just get this one example, and I think it'll be pretty good to go on the homework. Again, it's more not a lot of number crunching, but more words and definitions and stuff like that.
That's the same as saying like f of x, right? That's usually what we end up saying in the textbook or.
The h of x versus.
Yeah.
The tendency is to use f, and if you need to use 2, then you use h and f. And the next one we tend to use is g, but you technically can use any letter you choose. Okay. So, if h of x is equal to negative x squared plus 4x plus 1, I assume that if this were the question, 2, everyone knows how to do that? Right? You plug in the 2 here, you plug in the 2, you get the number out. Okay. So then let's do one that's just a little messier. Is instead of plugging in a nice number, we're plugging in a plus 4. Okay? So I'm going to rewrite our equation, negative, square it, and I'll put some big parentheses in where the x's are at. And now this is what's getting plugged in. So I'll put in a plus 4, a plus 4. So we need to FOIL that, right? So I'm going to actually write it out twice. A plus 4, a plus 4. And this here, I can just go ahead and distribute that, right? So I have 4a plus 16 plus 1. And we'll go ahead and FOIL that one. And I'm going to keep hanging on to that negative here just a little longer. So that'll give me a squared plus 4a plus 4a plus 16 plus 17 out here. So of course we're going to combine like terms there, right? But we also need to take this negative and distribute it out to everyone. So we have negative a squared minus 8a minus 16 plus 4a plus 17. I know I'm going a little fast right now, huh?
Yeah.
Go ahead, ask away.
The whole FOIL thing, sorry. You do the first one, and then you do the outside one?
You know what? That's funny. I say the word FOIL. They invented that after I did math. I simply take each of these has to be multiplied by everything here. So that's why I take here, this is going to be multiplied by the first one and by the second one, and could be the third and fourth if they exist.
And then the 4 by the
First one, by the second one, by the...
and that's it.
Yeah, that's the way I keep track of it. Yeah. I use the word FOIL, but I'm actually not foiling, according to the first in or out or last or whatever they do. Okay? And so now over here, to finally add it all up, we have negative 8a and positive 4a, so we have negative 4a plus 1. Yeah. Okay. So I think that'll be the hardest problem you'll probably run into while you do the homework.
Oh, that's right. So you'll multiply that negative, right? That's why everything.
Yes, that's why I kept hanging on to the parentheses and that negative sign. So I want to do all this stuff first, and then I...
Right. And that's why the 40 and 17 are still positive.
Correct. Yeah. All right. So I hope you have a good weekend. And I guess I will look at your homework then on Monday. It looks like. Unless you have free time to hang around afterwards here.
We have quiz on Wednesday.
We did have a quiz on Wednesday.
Well, I had to save that financial.